Hello everyone, welcome back. This is 2-6 circuits more on piston extended circuits in the compact Redstone series. I'm NewcomerMC, and today we are going to discuss more on some advanced double piston extender circuits and also going to introduce you some triple piston extender circuits. And meanwhile also bring up some extender principles to you so that you can learn more fundamentally how extenders are meant to be built and some principles within it, and to make your life easier basically. And throughout the video I might use some short terms. For example, I might use DPE for double piston extender or TPE for triple piston extender, so just be aware. And without further ado, I would start on with the extender principles first. So the first concept I want you to learn here is a concept called auto retraction, which is basically the use of butt powering to power the retraction of the front piston. So this applies for the case for upwards DPE or horizontal DPE. And to facilitate automatic retraction via butt, you either want to do two of the methods. The first method is to power the bottom piston with a long pulse and one tick the top piston with a 1 tick delay. So for example, like an observer. So you can see here this would work. Same for this one. This will also work. I'm sure that you have already learned these in the previous extender video. I think it's 1-8 basic circuits, basic extended circuits. So yeah, these should be familiar to you. But another method which you might not have learned yet is to power the bottom piston with a 1 tick pulse and power the top piston with a 1 tick pulse as well, but then with a 2 tick delay. So here we see we have two observers, and this works just as fine. And the sticky piston, the front one, will also facilitate auto retraction. So same for this case actually. So yeah, so this is how you can do auto retraction for these two kinds of DPEs. And yeah, it is going to be very useful because by following this principle, you can basically already tell what works and what doesn't. And for example, these. So you might have seen this setup here already. This is where I explain the conductor principle, in which you can see for the retraction, it doesn't really retract the block here. And for this one, it is even worse because it cannot even retract the front piston. So yeah. And the conductor principle is actually introduced in 2-3 toxic polarity racing condition and their applications, although there's a bit more to that because when I introduced the conductor principle, I didn't really specify all of the combinations that you can have. So yeah, I will explain it more here. But first, let me just show you the horizontal versions. You can see this is exactly the same. This cannot retract the block, while this one's even worse. It cannot even retract the front piston. And here I will introduce a revised conductor principle to you. So the back piston, there are some situations where the back piston can retract the front piston on under some situations. So the first one is that the observer is powering the observer powering the front piston is detecting a conductor. So like here, so you can see the observer that powers the front piston, like this one, is detecting through a conductor, like this node block here. And this automatically allows the back piston to retract the front piston. So that's the first rule. But then there are also other types where you would have an observer that will power the back piston, and then with another observer detecting this observer and powering the front piston. Now, if you're having this case, then you have some additional conditions that you have to satisfy. Is that this observer must be detecting from one of the following components here: rails, node block, hoppers or droppers, dispensers actually, but then I don't really care about dispensers. So yeah, you can see in this setup here, instead it actually works. Like the back piston will retract the front piston. Still, the front piston won't extend and retract, of course. And this means, in other words, the back piston cannot retract the front piston if the condition is that the observer is detecting another observer, or a redstone lamp, or a piston. Actually, the piston should represent any block state changes, because any block state changes would still not work. But you can resemble this by a piston. And also, all of these components, if you are powering it by a player input. So, if you have any of these situations satisfied, then this back piston is not going to be able to retract the front piston. Just no. So, hopefully this doesn't confuse you a lot. The revised conductor principle has just some additional conditions that you need to consider. But don't worry, if you are a bit confused, then you can always check out the document. Link is in the description, as well as the work download actually. So don't worry, you can always follow that if you want to. But anyways, we'll move out from the revised conductor principle to another concept, which is the concept of doing single double poles for a DPE. So this is for the cases of downwards or horizontal DPEs. So you can see that this, for example, is a single double pulse generator. So it will generate a rising, it will generate one pulse during the rising edge and a double pulse during the falling edge. So this allows this DPE to extend and retract actually fully. So same for this one. So as long as you can have a circuit that works with a single pulse for the rising edge and a double pulse for the falling edge, this piston extender is going to work. So this is just a concept I will introduce you, and this is going to be useful in a lot of your piston extender circuit building. So make sure that you remember this. I mean, to be honest, it's actually not even a new concept, because you will probably know that a single pulse is just normal, and then a double pulse is just that this sticky piston would retract, and then this sticky piston would be able to extend and retract due to racing condition. So it isn't really anything new, but then just pointing it out to give some pointers to you basically. So yeah, anyways, so now I have explained all of the extender principles, I can move on to actually present you the extended circuits I have. So we are going to start off with some advanced double piston extenders. So not those typical 4 tick to the back piston and then with an observer powering the front piston like this one. We are not going to introduce these because, quite frankly, you would have a lot of situations where you are limited to a volume and you cannot place the 4 tick repeater, for example, at the back, because that would just increase your door volume. And to avoid this, we would basically want the double piston extender to be always occupying at its limits, which is 2 blocks from the wall or the floor or the ceiling. So excluding the wall, floor, or ceiling layer. So yeah, we always want to have 2 blocks here, like these 2 blocks occupied by the double piston extender. That is the limit. We want to always follow the limit. So yeah, now I'm going to show you. So this is the first one. It's a lever input upwards double piston extender. It's not locational because this dust will prioritize the front piston, of course, than the back piston due to racing condition. So don't worry about that. Another one is actually very similar, except it just uses a block, and this sticky piston is going to be butt powered by this dust, so don't worry. And then you can absolutely be sure that this isn't a locational, because obviously this dust is powering this piston. But even then, this circuit is also not locational in any way. And yeah, speaking about piston extenders, I might want to add some bit more definitions, because you later would encounter with some piston extenders that are a bit unusual. So usually when I say piston extenders, I mean standard piston extenders. Standard piston extenders is just basically a piston extender that can fully extend a block. For example, you can just place the block here, and then it can also fully retract this piston, the block here, rather than, like, for example, these that doesn't really retract the block fully, or doesn't even work, like this one. So yeah. So this is called a standard piston extender. I'll just refer to piston extender for short. So yeah. Now here comes the most important one. To be honest, for double piston extenders, there are only 2 or 3 circuits that are a lot more important than any other circuits, because the other ones you can always figure it out by yourself. But some of these that you might not be able to. And the peculiar one is this one. It is a 2-poles input upwards double piston extender, and you can see it's 2 poles because you need a stone button, for example. Although I will also tell you that the minimum pulse length you need for this is actually 4 ticks, 4 tick pulse to an observer. Now, this circuit here, you might think, hey, that doesn't really work. How does this work in this circuit here? Because, you know, it is a dropper. Like, dropper is supposed to just have a 1 tick delay, and then it would even get buttered from the block on top, and then it would just break everything. Now, that's because how you're building it is not correct. So I'll just show you how to build it. If you're going to build it like this, this is not going to work, because this dropper is obviously going to be buttered by this block here, and then it will get updated by this piston here, so it's just not going to work, and this is not going to even extend as well. And remember that we recall from this auto retraction principle that you need a 2-tick delay here. So how do you facilitate for a 2-tick delay with 1 observer? Well, the answer is actually to butt this dropper. Now, what will be the difference after butting it? It basically means the dropper is currently now powered, and the observer will also power the dropper, but then the dropper is already powered, so it doesn't realize anything for this observer. And when the observer turns off, the dropper will also turn off, and finally this observer would detect it and power, so creating an extra 2 game ticks of delay, basically. And this observer will power this block, and then this piston will also update this dropper, and the dropper will just stay on, basically. It will not turn off. So every screen is bugged, but yeah, anyways, you can trust me that this dropper is actually butted. And then you can see, even though this is literally just 1 observer, it actually has 2 ticks of delay, or 4 game ticks, because of the butted dropper. And there's some things to notice. This setup here, although it's going to be very useful, because you can always have, like, you can always do some diagonal double extenders like this. But then one thing you need to remember is that you cannot update this dropper in any way, for example with another observer. So this essentially means if you're going to have this circuit right here, it will already not work, because this observer is already updating this dropper, so it doesn't work. And of course you cannot have anything like a piston that is going to power at another interval. This will also update the dropper. This is not going to work. So yeah, just make sure that the dropper is not affected by any other components, and also make sure to butt the dropper, of course, and you'll be fine. So that will be the case for this circuit here. The next one is also important, although it's actually quite simple. It is just a redstone torch to this here, this back piston, and then you can see it just works. It's basically the same as having a repeater, and then an observer, and then a block. It's literally the same, except you can see the repeater needs a block support at the bottom, but then, you know, torches doesn't. So this is a nice way to fit your double physics extender too high. So yeah, of course you need to notice that you need to inverse this again. So make sure not to mess up your logic. For example, you think that both of these can serve as input, while this is literally an AND gate. You will need to power both this one and this one in order to have the double physics extender to even work. So yeah, don't mess up these simple things, I guess. And yeah, this is also one of the downsides for this, because you can only have one input, and that is specifically from here. You cannot access to this dust. You must access to this torch. So yeah. Now we're going to discuss some other silly DPEs. It's not really that important, but then just showing you because for your reference, basically. Now, going to introduce two more types of DPEs. The first one is actually this one, which is a 2-pulse input. And you can see this double physics extender actually does not leave the block here. Instead, it will retract it back down. And this is, I would define it as a pushing DPE. And yep. Also make sure that you would input 2 1-tick pulses here. Also, I forgot to mention, I've mentioned this has to be 4 ticks to an observer. This is at least 3.5 ticks or 7 game ticks. And yeah. And for this one, actually, I'm not going to tell you, because the delay between the 2 pulses here is left as an exercise. Exercise 6.2 would be the question that asks you how long the pulse length must be, or the minimum length of the pulse needed for this extender to work. So that will be in exercise 6.2, and don't worry, there will be answer to it, so you can just check that out. But yeah, anyway, so main points, this is a so-called pushing DPE. And not to be confused with this example, I call this a pusher DPE, because if you just place a block here, you can see it just pushes it. It doesn't even retract it. So this is called pusher DPE. And you can always use the conductor principle to just make this. It's literally the same for any direction, to be honest. So nothing special here. So yeah. For this here, you want at least 2.5 tick pulse or 5 game tick pulse to this observer. So yeah, that's all for upwards DPEs. I'll go on to horizontal DPEs. So one of the interesting ones is this one, although it's not that useful because it occupies both sides. And you can see here, occupying both sides and occupying one side actually makes a difference, because it depends on how much circuitry space you have. And yeah, usually occupying on only one side is better than occupying both sides, because you know, you're occupying more space, and just having from one side is, you know, usually better. But yeah, anyways, so we have a 2-side one, and this is the advantage of this is that it's only powered by a 1-tick pulse, just one. It will retract by itself. It's a bit weird because it basically relies on the clock. This piston is going to power this dust here, which is going to power this piston back again. And once this piston is able to retract, it will power this block and then powers this piston. And you know, by raising condition again, yeah, this front piston is going to extend and retract. So nothing special here. Another one is going to be derived from the single double pulse principle. It's just this, so this works. So you can see, this is how you can, for example, to fit your circuitry into a 2 white space for the sides. So yeah, it's just that, nothing much. And for this here, you want to have at least a 3-tick pulse running into this sticky piston. And notice that you do not want to run 2 1-tick pulses to this piston. This is not going to work. You will need another setup, which is actually asked in exercise 6.1, just for your information. But yeah, anyways, should be very simple actually. Everyone should know this. Yeah, anyway, so yeah, make sure you don't run 2 1-tick pulses to this sticky piston. You need to run a short pulse at least. A 3-tick pulse is the minimum. Yeah. And we have another pushing extender again. It's literally the same thing. So again, this is left as an exercise for the minimum pulse length in exercise 6.2. So yeah. And another one is a pusher DPE, which is literally the same circuit over and over again. I'm not going to go deep into it. So yeah, basically that's all for the horizontal DPEs. I'll go on to the downwards ones. So the downwards ones, this is an example, is again taken from the single double pulse principle. So, you know, this works as a full DPE. And again, this is the minimum pulse length is 3-tick pulse or 6 game ticks. So yeah, nothing special here. And another one is this 2-pulse input downwards pushing DP is a pushing one because it detects a double pulse basically. So yeah, again, for this one, if you want to know, I should say, the minimum pulse length again is left as an exercise, although it's slightly a bit different because this only has 1 observer instead of 2. So the pulse length needed, the minimum pulse length needed is obviously a bit different. So yeah, still exercise 6.2 is related to this one, so I'm not going to tell you the minimum pulse length needed. And another one is just a pusher DP, literally this again. So again, 2.5-tick pulse will work. So yeah, that's all for downwards DP already. We are going very fast, so I would go on to have one special example. That is a semi-floor hipster. So this is a semi-floor hipster, and previously you might have seen the Melon BP semi-hipster. Which is, for example, this one. You can also have a dropper hopper here. I'm not going to care about that too much. So basically, you would have 1 tick here, and then just do this. Then 1 tick here, and then you do this. So yeah, this is the Melon BP floor semi-hipster. So yeah, but then the downside you can already see is that it is a 3-high bottom, so not good. You want a 2-high one. So here comes the 2-high one. This is, as I've seen, first developed by NewcomerMC. I'm not sure if he's the first one to build it, but then I'm just going to assume that he is. So anyway, so the working principle is again very similar, and yeah, and you can see that it actually uses this dropper again. Although this time we don't have to, but it will just do the things by itself, so you don't have to worry about it. So yeah, if you're very interested in the principle of how this works, you can always analyze it by timings, but you're going to do the work yourself. So yeah, just showing you this circuit is useful. That's it. So we have already went through all of the DPEs I want to show you today. Now I'm going to show you the TPEs, which is going to be a new topic. I'm not sure if you yourself have already built a TPE by yourself. If you have actually completed the entire introductory topic series, you should have a working TPE by yourself. But then we want some compact ones, of course. We want, for example, a 3-high one or a 3-wide one. So, you know, having some standard circuits would be pretty nice. This is a nice one. So it is a wooden button activated TPE. It's a bit derpy, but then it works. That's the most important thing. This is also the exact same example from 1-5 input methods. So if you have seen that video, you probably will remember that some sort of this circuit exists. So yeah. And now it might be a bit inconvenient for people to have a bottom input here, because you basically need to have another side to power this, or you need to power it from this side here. So some say, hey, it's going to be inconvenience, and that's perfectly reasonable. And that's why we also need to develop some methods to power it from the other side, for example, from here. So hence we have a setup like this. This is not an exact circuit, but it shows you how it works. So basically, if you have this configuration like here, like a snake, it's going to do the pulses. You can verify this circuit works by timings analysis and some piston properties by yourself. So yeah, basically, if you're going to give 4 pulses to this, it's going to work. Or you can give 3 pulses to it, but then it has to be in a specific delay. So each pulse must be basically 4 ticks from each other, or 8 game ticks. So yeah. And how you can achieve this? Well, you can achieve this by, for example, this circuit here. This generates the first 1 tick, and the 4 tick generates the remaining 2 4 ticks. So two 1 ticks. So yeah, this has a specific delay required such that it will work. So yeah, this only requires 1 pulse. So pretty nice. Another way you can do this is via hopper ROMs. So this has 3 wooden shovels in it, and if you really want to make this very slow for some reason, you can always replace them with snowballs, but then you would need to have a signal string with 4 to here. But yeah, anyways, this works. This has the exact same delay actually, surprisingly. So yeah, the same thing works. And basically I'm just going to introduce this configuration of the TPE to you. And there are also some other very useful configurations I'm not going to introduce here, because usually those are going to involve with entities. So we haven't really learned about entities yet. I'll put those into the entity one, the video one. So yeah, anyways, we'll move on from the downwards TPE to a horizontal TPE. This is an example. So basically just remember that. You might think how it works. It's not really that hard to understand. So is this far enough? Just put. Okay. The most important thing is how this works. So basically you have this here, powers. This observer is going to power this piston here. So like this. But then you can also see this observer is going to power this block, which can butt power this here. So this piston actually receives a 2 tick, while this piston is going to get updated by this piston. So when this observer turns off, this is going to turn off, and this being extended will also turn off, and that actually can spit out the block like so. So all we need later is just another pulse here, and this will automatically do this. So we just need 2 more pulses, this here, this here. So this, and then we can have a redundant pulse here, and then this here, this here, this here, like so. That's just how it works. Nothing special here. So yeah, it's a bottom based one, and I don't think you're really able to find a good lever one, to be honest. So yeah, bottom one would be the best choice, I guess. And usually people would most likely going to be using the downwards one because you have bots to help you, so it's usually going to be a bit more useful for that case. Now we are going to move on to a upwards TPE. Upwards one, unfortunately, it doesn't have some good TPE examples. The best one you can have without entities, again, is a 4 high one. This one is by Bruhjef. So, because the difficulty with upwards TPE is that you would need to have an observer pushed into the piston stack to power the piston top. And that is an extra difficulty, so why would anyone want to mess with that? You basically don't, unless you're forced to. So now obviously there are going to be smaller TPE circuits than this. Actually, it's not that obvious, it's just beaten recently. But then it uses entities, and yeah, again, I'm going to introduce that in another video. So there isn't a good way to actually wire a 3 high upwards TPE than to just doing it manually. So there isn't a well made circuits that you can use to make a TPE, but then I would encourage you to wire it by yourself. So here are the two setups I have. So you can see that from this circuit here, it basically is just powering the bottom one, powering the top one, the middle one I should say, and then powering the bottom one again because this is a lamp. And if you have realized, this is literally just a pusher DPE for the circuits here. And then we will have this observer and the voltic here that powers basically this double piston extender here. And due to this being an obsidian, the first time it powers, when the input powers, this piston is not going to be able to extend, but then this dust will update it such that it extends, and this voltage will actually allow this sticky piston to push this observer up to power the piston here. So that's basically how it works. And the second time, you can see it basically is just another DPE by itself. So we can take the concepts from here and to apply it to here. So what we need to do is to power this first, do this, and then this will do the thing by itself. Unpower this, and then just do this again. And this will automatically does everything. So yeah, same thing for here. And I must have gone to places. So yeah, that is a valid setup taken from the concepts of this triple piston extender, and that's how you can make this into a free high space. Another way, which is a bit more complicated but then it's still very useful, is actually this setup here. This setup is from a door, the 468 block 6x6 seamless funnel door by Red60, NewcomerMC, Nacay, and me. The bottom setup here is specifically designed by these two. So yeah, but anyways, it's actually quite simple to show you. So all we need to do is actually this and then this. So this is just going to power the bottom piston. This is a 4 tick running into this here, 2 ticks after running into this here. We'll see why, because it will need to do this animation and then run a 3 tick to here and it would do its retraction. So we can see the retraction actually works. So a bit derpy, but then still it works. So yeah, again, if you want to verify this circuit by timings, you can obviously do so. I would encourage you to do some timing practices sometimes to make sure you know how the circuits work. and perhaps maybe develop one useful one with yourself. So yeah, this circuit here, you're basically forced to have a second or third layer towards this side. So, but then it's still going to be useful in some cases, I believe. And most importantly, this circuit is useful because you can always move this setup here to here, such that it allows you to have another one of these triple base extenders here. So that's why this is used instead of the one here, where you are required to have this circuitry here to cater for this triple base extender. First, this triple base extender is guaranteed to be a triple base extender by itself. It cannot have an adjacent triple base extender next to it. So that's why this setup is used instead for the case in the funnel door. So yeah, that explains to you why this setup, even though it is a bit more complicated, is still very useful indeed. There are also some other sequences that you can apply. Maybe I'll just show you one a bit quickly. So the primitive one is actually this here. So 2 pulses here, and then we have this here, extend it, retract it. It's basically everything that you can think of. I'll just place this here, and then just do this again, then do this. You can see it requires a lot of pulses, so it's not really that viable, but then it still might be useful in some of your cases. Also, this is supposed to be a longer pulse to allow this piston to retract, so that you don't have to do 416. So yeah, it's going to be again a bit derpy, but then that's just how it works if you want a free high bottom triple extender. So anyway, that's all of the extended circuits I have. And just to mention here, first off, if you want to learn more about some DPEs and TPE circuitry, I would highly suggest you to watch the 2-10 basic entity usage and entity circuits. This video is going to include entity DPE and TPE, although it's not uploaded now because I haven't made it, but then it will be uploaded soon, so make sure to check that out. The second thing is that I'm planning to establish a circuit database to include some important circuits and setups discussed, so probably including some here. So it's still work in progress, of course. I probably might start working after I finish the series, for example. But then yeah, if you're a viewer from the far future, you're probably going to be able to access this database, I hope. So yeah, that's all I have to discuss for the extenders today. I'm going to go on to discuss some of the exercises. The exercises for the first 2 questions are actually very simple. It's just asking you why this circuit doesn't work, and to build a circuit here that makes it work. And then the second one is to discuss the timings, just telling you to do some timing analysis. It's going to be very simple if you have already consolidated your knowledge in 1-11 introduction to timings and 2-4 ticket counting, input bug, and more timings. So yeah, it shouldn't be that hard, to be honest. But then the third one is going to be a challenging one, because that is where a new type of question appears. It is to tell you to build a piston door with a volume restriction, actually. So 528 blocks. That's the maximum volume that you can have for this door. So you might think, how it's going to be appear in this door? Well, basically what I've designed for you is that you can have the wiring space like this. So 3 on top, 2 side, 2 side, and then 2 bottom. Or you can have this as well. So one side you have 3, another side you have 2, but then the top bottom will both have 2. I do not suggest you to do a bottom triple. It is very not recommended from me because it's probably going to be very hard for you. I'm not sure if your Redstone knowledge is going to be able to do this. If you want to, you can always do this as a challenge. I don't really care. You can definitely make something work, to be honest. But then, for simple and yeah, for the sake of simplicity, I would suggest you to just use one of the triple circuits I've introduced you for the triple. And yeah, make sure to plan your piston layout first and consider how much space you need for the triple piston extender. So that's all my advice I can give to you. And don't worry if you're struggling, you can always find answers from the back. So yeah, and as this question here involves the asking of timing analysis, this also means that there are going to be some wordy answers. So a Word file is going to be provided to you in the file along with the work downloads, the documents and stuff. So you can always check that file to verify your answers. And also, actually the answer for this one is also based on words, so that can also be found. So yeah, only this here and this here require circuit building, so you can always check that out at the back. And obviously I'm not going to be able to cover all of the answers because you're building a piston door, so it basically means infinite possible circuit combinations that you can have. So I'm just going to include one that shows you the simplest form of how you can use the circuits that I've introduced you and some prior knowledge of extenders that you can use. So yeah, you might be shocked by how simple this is, although I said this is a challenging question. It's actually, well, at least to me, very simple. But then yeah, go ahead and give it a try. And good luck on this question, I guess. And yeah, that's all for me today. Thank you for watching. I'll see you in 2-7. I'm going to check out what it is. It should be circuits dropper circuits, if I'm not wrong. Yeah, circuits dropper circuits. So yeah, I'm going to see you in 2-7. Thank you.